Hello everyone and welcome to Concepts to Grades, where we convert all your concepts to grades. In this video, we will be tackling the CBSE Class 10th Maths Chapter 1 Real Numbers. Here we will see the fundamental theorem of arithmetic, HCF and LCM and how they are related, and we will learn how to prove the irrationality of some numbers. From the CBSE 10th board perspective, this chapter has a weightage of 4 to 5 marks. So let us get started. Fundamental theorem of arithmetic. Before we start with the theorem, let us revise some basic concepts of prime and composite numbers. As we know, all natural numbers are divided into prime and composite numbers. Prime numbers are numbers which are only divisible by 1 and itself, and every other number which is divisible by other numbers other than itself and 1 are called composite numbers. The fundamental theorem of arithmetic states that every composite number can be written as a product of powers of primes. That is, every composite number can be expressed in the form of a product of prime numbers. So let's take some examples to understand better. 6 can be written as 2 into 3, which are two prime numbers. 24 can be written as 8 into 3, but 8 is not prime, which can further be written as 2 into 2 into 2 into 3 or 2 power 3 into 3. Similarly, 324, if we prime factorize it as shown here, can be written as 2 power 2 into 3 power 4. The process of writing a number with its prime factors is called the prime factorization of the number. This is what is the fundamental theorem of arithmetic. Using this, we generally find HCF and LCM, which are highest common factor and least common multiple. Let us see what this means. Highest common factor. Let us understand what this means physically first. Let us say you have 6 chocolates and you have 9 apples. You want to make groups of this such that each group gets the same number of chocolates and apples. How will you split it in groups equally? Well, you can do some trial and error and realize that you can make 3 groups where each group has 2 chocolates and 3 apples. Now, how did we arrive at this is nothing but HCF. So HCF, the highest common factor, is the biggest number that divides 2 or more numbers exactly. So in the previous case, where we had 6 and 9, if we write all the factors of 6, which is 1, 2 and 3, and all the factors of 9, which is 1 and 3, the biggest common factor in them is 3. Hence, we could make 3 groups in the previous case. Similarly, let's take 16 and 24. For 16, the factors would be 1, 2, 4. And for 24, it would be 1, 2, 3, 4 and 6. The highest common factor here is 4. Remember that HCF is all about maximum equal grouping. So whenever you want to divide things equally or split things equally, or you want maximum possible groups, which is common for both, you go for HCF. Let us look at least common multiple or LCM. Consider a similar case where you have one bell that rings every 12 minutes and another bell that rings every 14 minutes. Now, when would the bells ring together? So when you want things to occur simultaneously, that is when you use least common multiple. Least common multiple is also the smallest number that both numbers can reach together. So when you simultaneously divide both the numbers 12 and 14 with 2 first giving 6 and 7, then with 2 again to give 3 and 7 until you reach at all prime numbers or ones and multiply all of them, then you get the LCM of the number. So here the LCM would be 2 into 2 into 3 into 7, which is 84. So this means those 2 bells would ring simultaneously after 84 minutes. So LCM is all about when things will happen simultaneously together again. Whenever you want things to occur again or happen again together, then you go for LCM. Let us see the relation between LCM and HCF. Well, the product of LCM and HCF is equal to the product of the two given numbers. Let us see this with an example. 12 and 18. So the HCF of 12 and 18, if I write all the factors of 12, which is 1, 2, 3, 4, 6, and all the factors of 18, which is 1, 2, 3, 6, and 9, the common highest factor is 6. If we take the LCM of 12 and 18, where we divide them simultaneously first by 2, then by 3, to ultimately reach 2 and 3, which are prime, the LCM would be 2 into 3 into 2 into 3, which is 36. So the product of LCM and HCF, which is 6 into 36, is 216. Also, 18 into 12 is 216. So the product of HCM and LCM is equal to the product of the given numbers. So if we have the HCF and LCM of the number and one number, we can find the other number. Let us solve some examples in this chapter to understand these concepts further better. Starting with the first question, for what value of n, 2 power n and 5 power n end with 5? Well, we know from law of exponents that a power p into b power p is equal to ab total to the power of p. So using the same logic, 2 power n into 5 power n is equal to 10 power n. Now let us check this for some values of n. N equals to 1, 10 power 1 will be equal to 10. N equals to 2, 10 power 2 will be equal to 100. N equals to 3, 10 power 3 will be 1000. So as I keep going for any value of n which is greater than or equal to 1, the number always ends with 0 and not with 5. So there is no value of n for which 2 power n into 5 power n ends with 5. This is also based on the fundamental theorem of arithmetic. Moving on to the next example. If a is equal to 2 power 7 into 3 power 10 and b is equal to 2 power 3 into 3 power 7, then the HCF of a and b is. Remember that HCF is the product of the smallest powers of each of the common prime factors in the numbers. So we have to take the ones with the smallest powers. So in b, the smallest power of 2 is 3. So we take 2 power 3. The smallest power, if I compare both, is 3 power 7, which is in b. So the HCF of a and b will be 2 power 3 into 3 power 7. Coming to the next question. The traffic lights at different road crossings change every 48 seconds, 72 seconds and 108 seconds respectively. If they change simultaneously at 7 a.m., what time will they change together next? So if in the question they're asking when would things happen simultaneously again, so we need to go for LCM. So simultaneously dividing 48, 78 and 108 with 3, then 2, then 2 and 2 and further on, we can write the LCM of 48, 72 and 108 as 3 power 2 into 2 power 4 into 13, which is equal to 1872 seconds. 1872 divided by 60 to write it in minutes would be 30.2 minutes. And the 0.2 minutes in seconds would be 12 seconds. So which is 31 minutes, 12 seconds. So the next bell would ring at 7:31:12 a.m. This is how we use LCM to solve such questions. Coming on to the next question, which is slightly tricky, which might trick you to find LCM, but it's actually something else. So in a teaching workshop, if the number of teachers teaching French, Hindi, English are 48, 80 and 144, find the minimum number of rooms needed if in each room same number of teachers are seated and all of them are of same subject. So let us break this down and not get carried away by the word minimum here and find the wrong LCM. So let us say there are 48 French teachers, 80 Hindi teachers and 144 English teachers. So the question asked number of rooms and not number of teachers in each room. We need to find the minimum number of rooms. How will we get minimum number of rooms? If we place maximum number of teachers in each room. So since we have to split them such that we get maximum teachers in each room, and this is about splitting the teachers equally where all of them are of same subject and all of them have the same number of teachers, we go with HCF. So minimum rooms implies maximum teachers in one room. So since this is group or splitting, we go with HCF. Prime factorizations of 48 would be 3 into 2 power 4, 80 would be 5 into 2 power 4, and 144 would be 9 into 2 power 4. So the HCF would be 2 power 4, which is 16. So each room will have 16 teachers. So how many rooms would be there? Well, there are 48 French teachers. Dividing them into 16 rooms, we will get 3 rooms. There are 80 Hindi teachers. Dividing 16 teachers in each room, we get 5 rooms. And 144 English teachers would be in 9 rooms. So summing these 3, 5, 9 together, we get 17 rooms in total. This was a little tricky question and also a prior year board question. So understand the question clearly before you start marking the answer. Next question. Find the greatest 3-digit number which is divisible by 18, 24 and 36. Again, let us not get carried away by the word greatest and understand the question clearly. We need a number that is divisible by all 3 numbers at the same time. LCM of these numbers will be divisible by all 3 and the multiples of LCM will also be divisible. So LCM would be the least, and from there we can find the greatest 3-digit number. So finding the LCM of 18, 24 and 36 by simultaneously dividing them until we reach either ones or prime numbers would give us the LCM to be 3 power 2 into 2 power 3, which is equal to 72. And all multiples of 72 will be divisible by 3 numbers. So the greatest 3-digit number is 999. If I divide that by 72, I get 13.87. So 72 into 13 or 936 is the greatest 3-digit number which is divisible by all 3 numbers. Again, before getting carried away by the words in the question, understand what we need and then solve the question. Would recommend you to try these 2 questions as homework and comment below your answers. I will discuss the answers to these questions based on the comment I get. Remember, maths is all about doing and not about reading. Practice more and more questions so that you can answer them much better. Pause the screen or take a screenshot so that you have this for later. Moving on to the next section. Rational and irrational numbers. Rational numbers are any numbers that can be represented in the form of P by Q, where Q is not equal to 0. And irrational numbers are any numbers that cannot be represented as a fraction. So, in this chapter, we will be proving the irrationality of some irrational numbers. So, let us see the steps and how we prove the number is irrational. Starting with prove that root 2 is irrational. The steps and the answer will be side by side so that you can see how we go about it. So the first step would be assume that the number is rational and represent it in the form of P by Q along with writing the condition that Q is not equal to 0 and P and Q are co-prime. So assuming that root 2 is rational, and it can be represented as root 2 equals to P by Q, where Q is not 0 and P and Q are co-prime. The second step is to square on both sides. So when we square on both sides, Q into root 2, which is equal to P, will be equal to Q square into 2, which is equal to P square. Now we need to prove that P and Q are not prime. How do we do that? 2Q square equals to P. So this implies that 2 divides P square. So if it divides P square, 2 would also divide P. So let us say P is equal to 2M. So if I substitute that in case of P square, I will get 2Q square equals to 4M square. Again, Q is also divisible by 2 because Q square is equal to 2M square, and if 2 is dividing Q square, it can divide Q. So therefore, P and Q both have another common factor other than 1, showing that they are not co-prime. Now we conclude that this contradiction is because of the wrong assumption. So we say that this contradiction is because of the assumption that root 2 is rational, hence root 2 is irrational. This is how we prove that a number is irrational, by first considering it as rational and then contradicting. We know from our 9th class that any rational number added or subtracted to the rational number is also irrational. So if the question says we need to prove that 3 minus root 2 is irrational, how do we go about it? Well, the first step again remains same, where we assume it is rational and represent it in the form of p by q, and here we consider p and q as integers as the condition. So once we have done that, we rearrange the equation. Here, root 2 will be equals to 3 minus p by q, or 3q minus p by q. Then we prove that the part which has integers is rational. Hence, the irrational part is also rational. So similarly, we can say since 3p and q are integers, 3 minus p by q is rational. Since then, because this is equal to root 2 is also rational. Here you can use the previous method to show that root 2 is irrational, or you can state, if it's a smaller mark question, you can directly say that we know root 2 is irrational, and because there is a contradiction, it is wrong because of the assumption that 3 minus root 2 was considered as rational. So hence it is irrational. This is how you prove irrationality in a real number where there is a rational number added to the irrational number. These are some of the questions that you can try where you prove root 7 is irrational and also prove 9 plus root 7 is irrational using the steps given below. This is one of the most famous question of CBSE 10th board, which comes for sure at least in your essay once. So preparing this would really help you. Comment below if you have doubts anywhere in this section and we can see how we can solve it. So we saw how fundamental theorem of arithmetic works and how we use it to find HCF and LCM. We proved the irrationality of numbers. Practice the try these questions given in this video and also the NCERT exercise questions. Comment below if you have stuck with any question and we will find the answer for it. Subscribe to the channel, comment below and like this video.